Today we're rocking with the rock doctor, Grant Arnold. But first, welcome to the third episode of the Numeracy Report. My name is Sandra Tambiduray, or Mrs. T by my students. I'm a teacher, math coach, mother of two, and a lifelong learner. This show is the answer to every time I've had a student ask me, what is the point of this? Why do I need to know this? So, you know what? I decided to find out. Today, I'm super psyched because we're talking to the rock doctor, Grant Arnold. And for the uninitiated of you out there that refer to the field of geology, Grant is the former president and COO of Canadian Royalties, where his responsibilities included directing and managing all corporate activities in a multicultural and multilingual setting, managing staff, contractors, and exploration activities for the rapidly growing company. His career spanned 30 years in mining and base metal exploration, where prior to his role as president, he was the VP of exploration for Canadian Royalties. And he also worked for Falcon Ridge Noranda, amongst other operations in Canada. He was responsible for directing the team that made two significant nickel discoveries in Nunavik that have since become mines. His discovery of the Perseverance zinc copper gold deposit that was later put into production also won him the internationally recognized Bill Dennis Prospector of the Year award. Ladies and gentlemen, put your hands together for Mr. Grant Arnold. Grant, I don't think I've ever met anyone who, made a career out of exploration. I mean, that must have been a fun career.
Absolutely.
How did you get interested in this career?
Well, I think I've always had an interest in geography, in rocks, rock collecting when I was a kid. It was just a natural extension of a personal interest that developed into a career.
Wow, that's amazing because you enjoyed your work. That's important. You took your interest that you've had and you figured out a way to make it work for you, and that is amazing. So, wanted to ask you, how did you use math in your career? Can you give me some examples of how you use math?
Well, mathematics is, it's all around you in what you do. Let's say you're putting together a budget. You have to be able to understand basic math, make a spreadsheet work, add things up, come out with a decent number, spread it out over a year, month by month expenditures, basic math for that sort of thing. Into the geological aspect of things, when I went through, we were required to do 2 years of calculus, which was fine. It was good for brain exercises, but I think I would have been better served if I had, other math training, relevant math training.
Mm-hmm.
One of the things that I've used quite a bit, actually, in my career, have been statistics.
Yeah.
When you're looking for a mineral deposit or an area that has potential to have mineralization, what you're looking for are anomalies. And anomalies are geophysical in nature, or they could be geochemical. Something that places these areas, out of the ordinary. Well, how do you define an anomaly? Well, when it comes down to soil geochemistry or rock geochemistry, it's numbers, and it's crushing numbers. And the way you do that is with statistics.
How did you use statistics to detect those anomalies?
One of the techniques that explorationists use, is soil geochemistry.
Hmm.
And early on in my career, I mean, we call it dirt bagging. You basically put a backpack on full of craft paper bags, and you go out with a soil auger and you take samples of the B horizon, which is basically the soil horizon underneath the humus. You consistently sample that soil horizon, and you do it on a grid pattern. So let's say you have a grid in the woods, and a grid is it's like sidewalks in the woods. They're cut or flagged lines that are parallel.
Hmm.
And let's say you have a 4 by 5 kilometer grid. You've got 20 square kilometers that you're covering, and maybe there's 100 meters between the lines. That's a lot of lines and a lot of samples. You might be taking a sample every 25 meters, every 50 meters, every 100 meters. So you go ahead and you collect all this data.
Hmm.
And at the end, you've got, back at camp, you've got, 1,000 bags of dirt sitting there,
Yeah.
shipped off to a lab. And each one of these samples is georeferenced with UTM coordinate or a grid coordinate. Anyways, it can be georeferenced, and then you get your data back, and you're going to be getting a whole pile of numbers. And depending on what you've asked the laboratory to analyze for, let's say you're looking for lead, zinc, copper, silver. You might analyze for those elements in the B horizon soil. So all of a sudden, you've got a whole bunch of data in front of you.
Mm-hmm.
So what do you do with that data? Well, you can go look for the high numbers and the low numbers and whatnot, and that might give you an idea. Okay, these areas might be interesting, but better way to do it is, okay, we want to make a contour map. And well, how do you contour? Well, you have a look at the statistics. You decide, through basic statistics, what are your, what's your average or your median, maybe standard deviations, and decide upon a contour interval, and then go to it that way. Then you compare that to, what regular background mineralization is in the area. What I say by background is, what does the whole area look like? I mean, are there above background anomalies present all over the place, or is it fairly quiet? You don't know that until you sift through the data. But anyways, let's say you come up with a nice area, say a couple 100 meters long, 100 meters wide, with anomalous geochemical values. Well, that might be a good area to start looking at, because all of a sudden you've got the soil telling you what the underlying rocks contain in the way of possible mineralization. Now, that's a first step, but that's an example of using statistics.
It baffles my mind that statistics is not a compulsory study for everybody. I feel like everyone can benefit from understanding random sampling and correlation versus causation, all those stuff.
Well, I have to agree with you, Santhra, because I wish it was a compulsory second year course, when I went through, because guess what? I had to teach it to myself.
You picked it up right by yourself. Like, was it always like that for you?
Well, I think, for math anyways, you need a reasonable foundation in mathematics to be able to learn more. You can't miss out on the basics and hope to grasp the more advanced stuff later on. But what made it a lot easier were those teachers and professors who went out of their way to show real life applications of what we were trying to do.
Right.
Just solving problems on the blackboard and doing exercises, that kind of thing doesn't work with me. I'm a tactile learner.
Right.
I need to understand what I'm doing, and and why I'm doing it, and be able to touch it and feel it.
Yeah. Yeah.
So no, I wouldn't say it was super easy, but even the best marks I got in university were in math courses where the prof was very good at explaining and making the class understand the practical nature of what we were learning.
Can you walk me through, how math models and sensitivity analysis are used? Because we had a conversation and you were talking to me about that. So can you tell me, can you explain how that was used in your career, and how knowledge of math helped you in those?
Well, let's say, rewinding back to talking about drilling off an ore body. Once you have, let's say, that number, tons and grade, then you have something to work with. You have tons and grade of whatever it is, zinc, copper, nickel, gold. You know that becomes one of the givens, and it's an element of the project that is now de-risked. It's there. The limits. There are no more surprises. As far as an ore reserve or a mineral resource goes. So, okay, you've got that. Presumably, once you're at this step, that stands a chance of being economic. There's plenty of mineralization out there that isn't, that nobody can make any money on.
Right.
But you've already done some back of the envelope calculations that state, okay, let's say your mineralization is worth about $200 a ton, and you can mine it for 100. Well, okay, you're ahead there. If it's worth $50 a ton and takes $100 to mine it, well, you put it on the shelf and go do something else, because nobody's ever going to make money with it.
Right.
So
Right.
You already have an idea. Once it gets firmed up that it really is worth pursuing, you have to do more detailed economic modeling. In the mineral industry, when an investment is made in a new mine or a new project, all the money is spent up front. There is no money made, zero, until the capital is invested in the project and the project is actually producing and generating cash.
Right.
So when you understand that, you realize the importance of discounted cash flow modeling. And let's say you have a 15-year mine life. Okay, you've got 15 million tons. You want to mine 1 million tons a year, and you need to spend X to get the project up and running. Y for your environmental bond and cleanup and stuff like that. All this money that has to go, up front, as capital expenditures into the project. When you get down to the financial modeling, you start realizing that you have a lot of variable parameters.
Yeah.
What do you use? Is copper $3 a pound that you use, or is it $4, or is it $6.25? What do you use? Well, you can go back and look at what other past projects have used in terms of parameters. Let's say mining costs. You can go through peer projects and, you can come up with, an underground mining cost of, let's say it's $60 a ton. Some projects might be 45, some projects might be 75, depending on how complex the mining is, whether it's the ore they're mining is narrow or thick. All these enter into account, but you'll get a range of values. So let's say your financial model, you know what your mill is going to cost, plus or minus. Let's say it's $100 million. But you can apply ranges. You can say, okay, if we're lucky, we get good bids, it might cost us $95 million. If we get caught up in a supply chain issue, inflation, blah, 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 it might be $120 million. So you can assume $100 million, but it's never going to be $100 million. It never will. So you can apply a probabilistic approach to financial modeling, where you can say, okay, well, I've got a lower limit for what my mill costs, an upper limit. I've got a lower limit on my metal price assumptions, my upper limit, foreign exchange. That enters into every project that is not domiciled in the United States, because commodities are sold in US dollars. So what's foreign exchange going to be? Well, you can look at past history and model that in a probabilistic fashion as well. And it's a big factor. I mean, if in this country, foreign exchange rate now is, about 1.35. You drop that to 1.2, it changes everything.
Yeah. When you're looking, especially looking at.
So if you apply a probabilistic approach to all your inputs, and as you were saying, causative parameters, figuring out which are the big ones that influence the project, with p-values and whatnot, you can build a reasonably robust financial model, but not one that generates, an answer, but one that will generate a range of answers. Allow you to do a sensitivity analysis. Okay, what does a 20% increase in metal price do? Let's say copper metal price do for this project, and you can plot it out. What does it change the net present value by? What does a drop in foreign exchange do? What does an escalation of project costs do? Capital costs. So when you're looking at some of these more advanced documents that companies file, all these things get filed, on Edgar, I guess, in the U.S., and SIDAR in Canada. Like you publish a technical report, and you press release it. You've got 45 days to file the physical report. And usually if the technical report is on like a bankable feasibility or pre-feasibility study, there is always a chart in there that shows sensitivities. It's a single chart, and it beats reading 200 pages of report. It distills what this probabilistic analysis does, for the project. And you can see in one chart, okay, this project looks good, or this one is like too sensitive to something.
Right.
Because there's many projects that people put through, and to make the project work, all they got to do is change a parameter. Oh,
yeah,
is $4 copper instead of the average, which is $3.50. Oh, look at that! The project's economic.
right.
Is that reality? No.
Yeah,
So you have to be able to um, translate all this fun stuff that you've been doing, in the field, uh, into a project, because that's what mining is about. It's about mining a commodity and making money with it. It's like Apple Computer, it's making a project and making a product and selling it for money. It's the
right,
same thing.
right.
And anyone who's successful today in business has to employ some degree of statistical analysis in all their processes. Otherwise, they've missed the boat.
I want to ask you, what is some advice that you would offer to a current math student who is perhaps interested in your career?
Keep at it. It's mental exercises that will help you in resolving bigger problems later on. It's a tool. It's a language, and it describes basically a lot of things that we can't describe in words. I would suggest to any student out there who's interested in pursuing a science background, to have to make sure they have a varied math background, not just whatever the university's dishing up in terms of required courses. Again, I go back to statistics, but linear algebra is probably another one that's useful. Talk to people in industry. Talk to people in industry that you may know, or through other people you could get to know, to find out exactly what it is.
Right. Yeah.
That you need out there in the real world, what's relevant and what's not.
Before we wrap up, final question, is there anything you would like to say to a teacher or a professor who's had an impact on your life?
Well, absolutely. Unfortunately, she's no longer with us, but Mrs. Wallace in grade 5. This goes back a long, long time. But she was able to motivate a really large class, and many of whom ended up doing some really amazing things in their lives. And she was just a good all-around grade school teacher, with a focus, a laser-like focus on basics, math, language skills, all the building blocks you need later on in life. And to all those teachers and professors out there, that have made the extra effort to show the relevance of what they're teaching. I mean, not just go through the motions and get the class over with. And those who will take the time with students who are showing signs of being gifted. I mean, I think that's important too. You can't boil down education to a single denominator. There are always going to be kids in the class who will excel. There'll be others that won't excel. that's going to be the makeup and composition of every classroom everywhere forever. But I think it's important for those teachers to take a little bit of extra time. If there's somebody showing promise, spend more time with them.
Yeah, I know. Yeah, challenge, the additional challenge for sure. So, this was very fascinating, and it's certainly a topic I'd, like to dive into deeper. Um, for now, though, Grant, thank you so much for your time. I really appreciate you being on the show and sharing your insights into exploration geology. And like I said, it's a topic that I find very, very, very interesting. So, and I did not know how much math and statistics, would be used in this career. So this was incredible.
Well, it's come a long way since pick and shovel. But what I tell people is, if you can't farm it, you have to mine it, and keep that in mind. Every single thing you use, in everyday life, just spend a few seconds thinking where it comes from, and you'll see that there's an incredible amount of things that we take for granted that come from the ground.
Right. Wow. That's beautiful. Mhm. Grant, thank you so much for your time.
You're very welcome. I hope I've been able to contribute.
Listeners, I hope you enjoyed this conversation just as much as I did. If you know anyone who is passionate about the way math is used in their work, whether it's yourself or someone you know, please reach out to me. Details are on my website, numeracycoach.com. If you enjoyed this content, please subscribe. And if you know anyone who could benefit from listening to this show, please share it with them. Until next time, adios.